So now we are studying rolling motion. So what is rolling motion? So rolling motion is a combination of the translational motion and rotational motion. Okay, so let's consider this wheel. Let's suppose it is moving on a frictionless surface. Okay, so it will perform only translational motion. Okay, this wheel performs only translational motion. Okay, so in translational motion, what happens? All particles of this body, they will move with same velocity, right? So let's call that velocity v. Okay, or velocity of center of mass, you can say VCM. Okay, so all particles of this body, they are moving with the same velocity v. Okay, so it cannot happen that some particles move with greater velocity, some with move with lesser velocity. Okay, if it happens, what will happen? The body will break, right? Some particles will move ahead and some particles will be left behind. Okay, so when body performs translational motion, when body moves in a straight line, all particles move with the same velocity. Okay, now this is translational motion. All particles are moving with velocity v. Then this is rotational motion. Let's consider this wheel which is rotating about an axis passing through the center of mass. Okay, that is the center of the wheel. So it is rotating with some angular velocity. Let's call it omega, right? So all particles within this body, they are rotating with angular velocity omega, right? But velocity of all particles will be different because the particle over here, it will be moving in this direction. The particle over here, it will be moving in this direction. The particle over here, it's moving in this direction. And particle at this point, it is moving in this direction, right? So if we consider any particle, okay, any particle at the edge, what will be its velocity? Its velocity will be omega times r. Okay, omega times radius of this wheel, right? So for this particle, velocity is omega times r, but it is in this direction. Okay, for this particle, it's in this direction, and for the particle at this point, it is in this direction. Okay, so now what is velocity of center of mass? It's zero, right? In rotational motion, its body is performing rotational motion about an axis which is passing through the center of mass and perpendicular to its plane, right? So velocity of center of mass itself is equal to zero. So this is translational motion and this is rotational motion. Now if body rolls without slipping, okay, if body rolls without slipping, then it is combination of translational and rotational motion. Okay, so let's suppose that this wheel is rolling on this surface. Okay, it's rolling on, sorry, on this surface. Okay, so what will be velocities of different points? What will be velocities of different points? Okay, we know that rolling motion is combination of translational and rotational motion. So if we think of any particle within this body, it is performing two kinds of motion. Okay, which motion? One translational, one rotational. So if you think of particle over here, it will have velocities due to those two motions. So what will be those velocities? One will be due to translational motion, it's v, and one will be due to rotational motion. How much is that? Omega times r. So if you consider particle at this point, it will also have two velocities, right? Velocity due to two motions. So velocity due to translational motion is v, velocity due to rotational motion is omega r, but their directions are opposite, right? The directions are opposite. Omega r is in this direction, v is in this direction. So what will be its resultant velocity? It will be v minus omega r. Okay, in what direction? In this direction, right? Then if you think about particle at this point, what will be its velocity? So v is, sorry, v is in this direction and omega r is in this direction. So it will be resultant of v and omega r. Okay. Then what about the center of mass? So for center of mass, it will be equal to v only, right? Because velocity in rotational motion is zero. Okay, the wheel is rotating about the center of mass only. Okay, so velocity due to this motion is zero. Velocity due to translational motion is v. Okay, and for particle over here, you can say omega r is directed like this. So velocity due to rotation, and v is directed like this. So now suppose this body, this wheel, it rotates without slipping. Okay, if it slips, what will happen? If it slips in this direction, that means v is greater than omega r. Okay, v minus omega r is positive. So v is greater than omega r. Okay, if it slips in this direction, then we can say that omega r is greater than v, right? But if it rolls, purely rolls without slipping, okay, it rolls like this. So for an example, yeah, I don't have any circular body. So if we consider rolling motion, okay, without slipping, the body is not slipping at all, okay, then what will happen? The velocity of this point will be equal to zero. Okay, it's not slipping in this direction, not slipping in this direction, it's rolling, purely rolling. Okay, so the body falls like this about this point. So can you see my hand? So this point is the bottom point. Okay, my thumb is the bottom point, and body, it rolls like this. So can you see the motion of this point? So this point actually, it is at rest. Okay, and other points are moving, body falls like this. Okay, so the point of contact changes. Okay, but velocity of the point of contact at the moment is equal to what? Zero. The body rotates about that point of contact. Got this? Yes, no? Yes, everybody? Indra? Okay, so if it happens, if body is performing rolling motion without slipping, if it slips, then either v or omega r will be greater, right? But for purely rolling motion, by what do I mean by purely rolling motion? Rolling without slipping. Okay, so for rolling without slipping, you can say v will be equal to what? Omega times r, or r times omega, you can say. So now everything is simplified. Okay, so velocity of point at bottom, okay, velocity of the point at bottom, let's call it point b. So velocity of b will be equal to 0. Okay, velocity of center of mass is equal to v, which is equal to omega times r. So velocity of this top point is equal to what? Since omega r is equal to v, we can say it is 2 times of v, right? So velocity of the point at top is 2 times of v, or you can say it is 2 times of omega r. And what about this point and this point? So if v is equal to omega r, what will be direction of velocity? It will be at 45 degrees, right? It will be at 45 degrees in this direction, because these two vectors v and omega r, they are equal. So velocity of this point will be at 45 degrees. Okay, like this, 45 with respect to vertical, you can say. Okay, or with respect to horizontal, if you want to say, it is minus 45, right? So here again at this point also, its velocity will be at 45 degrees. Okay, and what will be its magnitude? It will be square root of 2 times v. Okay, so let's call these points. Let's call this point C, this point D. Okay, this point is A, suppose. So velocity of C is equal to velocity of D, and okay, in magnitude I can say it is square root of 2v, that is equal to square root of 2 times omega r. Is it clear? So let's see kinetic energy of rolling motion. So this body, it is performing rolling motion. Okay, rolling motion. So we have seen rolling motion is combination of translational and rotational motion. So if this body rolls, if this body rolls, it will have two types of kinetic energies, right? So kinetic energy of rolling motion is sum of kinetic energy of translational motion, you can say, and kinetic energy of rotational motion. Okay, so we had started this chapter itself with the kinetic energy of rotational motion, right? And how much is that? It is half of I multiplied by omega square. Okay, it is half of I multiplied by omega square. And kinetic energy of translational motion, we know it is half of mv square. Okay, kinetic energy of rotational motion is half of I multiplied by omega square. So we had started with this concept itself. Okay, that kinetic energy in rotational motion is half of I into omega square, and from there itself we defined the concept of moment of inertia. It is inertia of rotating body. Okay, so then now in last lecture we studied about the radius of gyration. Okay, radius of gyration. So in terms of radius of gyration, what is moment of inertia? Radius of gyration. Moment of inertia of body in terms of radius of gyration is it is mk square, right? It's mk square. Oh, I wrote one small m, one capital M. Okay, it's mk square, right? So we can substitute that over here. So what do we get? We get kinetic energy of rolling motion, it is equal to half of mv square, okay, plus half of mk square into omega square. Okay, and then what we can do is either we can convert this omega into v using this formula, because in rolling motion velocity of center of mass is v, okay, and it's equal to omega times r, right? So either we can convert v into r omega, or we can convert this omega into what? V, right? So let's write that omega is equal to v upon r. Okay, omega equals to v upon r. If I write that, what do I get? So this is equal to half of mv square plus half of m multiplied by k square. Okay, and omega is v upon r, so it is v square upon r square. Omega square is v square upon r square. Then you can take mv square common, half mv square actually you can take common. So what will be left from first term? Okay, what is left in first term? 1, and in second term it is k square divided by r square. Okay, so what is kinetic energy in case of rolling motion? It is half of mv square multiplied by 1 plus k square upon r square. This is one formula, right? This is one formula. Then we can also write v is equal to r into omega. So in terms of omega, what we get? So if we write V equals to R times omega, okay, and we substitute that here, okay, or in this formula, where in this formula, okay, if we substitute that, what do we get? So it will be half of m multiplied by r square omega square plus this term, okay, half of m into k square into omega square, right? So I can write it as, okay, kinetic energy of rolling motion V equals to r omega. Then what do I get? So it is half of m multiplied by r square omega square, okay, multiplied, sorry, plus this term, half of m multiplied by k square omega square, okay. Then what we can do is we can multiply and divide by k square in first term, okay. If I do that, what do I get? Half of m multiplied by k square, okay, r square upon k square, right? So what did I do? I just multiplied and divided by k square, okay. So what do I get? So mk square is moment of inertia, right? Mk square is moment of inertia. So I can write this as half of I, the moment of inertia, into omega square multiplied by, from first term you have r square by k square, from second term you have 1, right? So it is r square upon k square plus 1. Okay. So we get these two formulae for kinetic energy of a body, kinetic energy of rolling body. So first one is in terms of mass. Okay, the regular formula, half of mv square multiplied by 1 plus k square divided by r square. Second one is in terms of moment of inertia. So in terms of moment of inertia, we can say it is half of I omega square multiplied by r square by k square plus 1. Okay, so is it clear? Okay. So let's suppose that there is any body which is rolling down this inclined plane. Oh, it always fails me. Yeah, good. So let's suppose this body rolls down this inclined plane, and this angle, suppose theta. Okay, angle between the plane and horizontal direction is theta. Okay, and the height is h. Okay, the height from which it rolls down is suppose h, and this distance is s. Okay, so this body rolls down with certain velocity, okay, and we know in rolling motion velocity of different points will be different. So what do I mean by velocity here? It's velocity of the center of mass. It's velocity of center of mass, right? So suppose that velocity of center of mass at the bottom is v. Now at top, when you just release that body, okay, will it roll down if there is no friction? What kind of motion this body will perform if there is no friction? So consider this body, right? So now suppose this is frictionless surface. Suppose this is frictionless surface and you push this body, okay? So will it slide or will it roll? It will slide. Very good. So this body will slide only, okay? It will not roll. Why? It's because for rolling you will need to change its angular velocity. So initially it didn't have any angular velocity. Okay, initially it didn't have any angular velocity. Now for rolling, you need some axis of rotation. Okay, so you need to fix that body at some point and then apply torque on it. Okay, so now if this is frictionless surface, so whatever force you apply, what will happen? Because it is not fixed at any point. The body is not fixed at any point. See, when you exert a force, any little force, it will slide. Okay, it will slide. So the body doesn't have any point about which it can rotate if there is no friction at all. If there is some frictional force, then what will happen? The frictional force will try to hold this point. Okay, it will try to hold this point, okay, at rest. So till the time the exerted force doesn't exceed the maximum value of frictional force, okay, the body will not move at all. Okay, and when it exceeds, what happens? So now frictional force tries to hold this point wherever it is, and therefore now this point is fixed. So when you exert an external force, what happens? There is a torque exerted about this point. Okay, there is a torque exerted about this point, and because of that torque, the angular velocity of body will change. So you got this? Yes, no? So frictional forces required for rolling. So see, there have been direct questions also. Okay, not exactly like this, but based upon this. Okay, so see, if it is if it is frictionless surface, okay, so what kind of motion a body can perform on frictionless surface? Sliding motion, right? Body cannot perform rolling motion. So some friction is needed for rolling. Okay, some friction is needed for rolling. So please keep this in mind. So let's consider rolling motion of this body on this inclined plane. Okay, so this body is released at the top of the plane, okay, from this point, and suppose it rolls down. Okay, it rolls down without slipping on this inclined plane. Okay, angle of inclination is theta, this height is h, right? So now we can say that this body will have only potential energy at top, and when it rolls down till this point, at this point it will have only kinetic energy, right? It will have only potential energy at top, and at this point it will have only kinetic energy. So we can say its potential energy gets converted to kinetic energy when it rolls down. Okay, so potential energy at top is equal to kinetic energy at bottom, or I will say kinetic energy of this body at bottom is equal to potential energy at top. Okay, so what is kinetic energy? This expression we have to remember, it is half of mv square multiplied by 1 plus k square upon r square. Okay, this is kinetic energy of rolling body. So body has velocity v when it rolls down till the bottom. So this is equal to mgh, right? So mm gets cancelled, okay, and from here we can find out what is v. So its speed at the bottom, speed at bottom is suppose v, it's equal to, take 2 on that side, so it is 2gh, take this term on the other side, it goes in denominator, so it is 2 times gh divided by this term, 1 plus k square upon r square, but this is v square, right? V square will be, take 2 that side and this term also on the other side, so it is 2gh upon 1 plus k square upon r square. This is v square. We want v, and that's why we'll take square root of this. Okay, so what is, sorry, so what is speed of the body rolling down an inclined plane? It is sorry, so what is speed of the body rolling down an inclined plane? Square root of 2gh divided by 1 plus k square upon r square. This is the formula. Okay, we have to remember this. Alright, so we want to find out acceleration now. So we can use this formula, v square equals to u square plus 2 times a multiplied by s. right? So how much is u? So we are just releasing the body at this point from the top point. So u is equal to 0. Okay. How much is v? We have found it out. This is the v. Okay. And what is s? So in terms of h, we can write down s. Okay. So what is relation between h and s? So this much distance is s. We can say s is equal to what? Or we can say sine theta is equal to h divided by s, and therefore s is equal to h divided by sine theta, right? Okay, so we can substitute this. So what do we get? So we get u square is 0, v is square root of 2gh upon 1 plus k square upon r square. So v square will be 2gh divided by 1 plus k square upon r square, and this is equal to, this term is 0, plus this thing is 2 times of a multiplied by h upon sine theta, right? So this h gets cancelled, 2 gets cancelled. Okay, we get acceleration equals to g sine theta divided by 1 plus k square upon r square. So if we take this sine theta on that side, it is g sine theta divided by 1 plus k square upon r square, right? So we get this formula for acceleration. Okay, and one more thing, so we can use s is equal to ut plus half of at square. Okay, and we can find out time, right? We can find out time. So s is equal to h divided by sine theta, u is 0. Okay, it is equal to half of acceleration is g sine theta upon 1 plus k square by r square and multiplied by t square. Okay, we will not substitute for s. Okay, so we can substitute afterwards when we want. Okay, so what will be t square? So it is square root of 2 times of s. Okay, 2 times of s multiplied by 1 plus k square by r square. Oh, sorry, this is t square. So 2 times of s multiplied by 1 plus k square by r square, and divided by, you have g sine theta. Okay, divided by, you have g sine theta. This is t square, and we want t. Okay, we want t, so we will take square root of that. We'll take square root of that. Okay, so this is the formula for t, time period. So square root of 2s multiplied by 1 plus k square upon r square divided by g sine theta. Okay, so is it clear, or is there a question in this? So that is a simple way actually to remember this. We'll have s is equal to half of a multiplied by t square, right? So t is equal to what? T is equal to square root of 2 times s divided by a. Okay, so in case of the linear motion, you have linear acceleration, which is g sine theta. Okay, so for body which is which slides down an inclined plane, we had studied this in last chapter. Okay, in force, that the formula of acceleration is g sine theta. So here what changes? This extra factors, this extra factor will come there. Okay, so it is square root of 2s upon a. Okay, for a, we'll substitute acceleration in rolling motion. So a is equal to what? G sine theta divided by 1 plus k square by r square. So that 1 plus k square upon r square is in denominator of denominator, so it goes in numerator. Is it clear? So we just have to remember this formula for the speed. and this formula for acceleration. And time period is equal to what? Square root of 2s upon a. So instead of acceleration in linear motion, which is g sine theta divided by, which is g sine theta only, we have to substitute acceleration in rolling motion, which is g sine theta divided by 1 plus k square by r square. If you substitute that, g sine theta divided by 1 plus k square by r square, we get this formula. So there is no need to separately memorize this formula. I will just say it is square root of 2s upon acceleration for the rolling motion. Okay. What is acceleration when body rolls down an inclined plane? It is g sine theta, okay, which is acceleration for sliding motion divided by 1 plus k square by r square. So if you substitute that, g sine theta upon 1 plus k square by r square, you will get this thing, right? A solid sphere, disk and solid cylinder, all of the same mass and radius, are allowed to roll down from rest on the inclined plane. Then so they are allowed to roll down from rest on the inclined plane. Then solid sphere reaches the bottom first, solid sphere reaches the bottom last, then the disk will reach the bottom first, all reach the bottom at the same time. This is the question. Okay, so now see the time taken by these bodies to reach the bottom. Okay, the time taken by these bodies to reach the bottom, it is given by this formula. Okay, so t is equal to what? T is equal to square root of 2s upon g sine theta multiplied by 1 plus k square by r square. This is the formula. Okay, so which is uh, which is the different thing for these bodies? Oh, I already circled it. So it is k, right? It is k. So if k is small, radius of gyration is small, then they will roll down in less time, faster. Okay, if k is more, then time taken to roll down will be more. Okay, so k is more, the time taken will be more. If k is small, then the time taken will be less. Okay, so what is moment of inertia of these bodies? Solid sphere is 2 by 5 mr square. Okay, that means radius of gyration is what? K is equal to root 2 by 5. Okay, root 2 by 5 r for solid sphere. For disk, okay, this is for sphere. For disk, how much is it? So moment of inertia is mr square. That means radius of gyration is, moment of inertia is half of mr square. So radius of gyration is r upon root 2. And solid cylinder. So for solid cylinder, it is mr square only. Okay, moment of inertia is, solid cylinder, it is mr square by 2. So radius of gyration is r upon root 2 for cylinder also. So for the disk and for cylinder, it is same, k is same, and for sphere it is less. Okay, that means the sphere will take lesser time compared to the disk and cylinder, right? Okay, so let's see this next question. A solid homogeneous sphere of mass m and radius is moving on a rough horizontal surface, partly rolling and partly sliding. During this kind of motion of sphere, option A, total kinetic energy is conserved. The angular momentum of sphere about the point of contact with plane is conserved. Only the rotational kinetic energy about the center of mass is conserved. And option D, angular momentum about the center of mass is conserved. Which one will be correct? When it slides on rough surface, what will happen? Its speed will increase, decrease. Decrease, no? What will happen to kinetic energy? Will it be conserved? Speed decreases, kinetic energy will be conserved or not? Not conserved, right? Speed is decreasing, no? Okay, it is rough surface. It's given its rough surface. Okay, and it is partly rolling and partly sliding. If it slides on rough surface, speed will decrease, so kinetic energy is not conserved, right? Then the angular momentum of a sphere about the point of contact with the plane is conserved. Okay, so angular momentum of sphere about the point of contact with the plane is conserved. Okay, this will be true. Why is this true? See, now if you consider the point of contact, so suppose this is point of contact, so now frictional force will be there. Okay, so if this body is rolling like this, okay, if it is rolling and moving in this direction, suppose in this direction, then the frictional force will act in this direction if the body slips in this direction, right? So frictional force passes through this point, the point of contact. Okay, and there is another force, gravitational force. So now this is center of mass. Okay, gravitational force acts through the center of mass, but the center of mass is above this point, the point of contact, right? The center of mass, sorry, this force, gravitational force also then passes through this point. Okay, so the line of action of gravitational force passes through this point. Okay, and the frictional force also, it acts like this. So there will be no torque due to the frictional force about this point, and also there will be no torque because of the gravitational force also. Why? Torque is equal to what? It is perpendicular distance multiplied by force. Okay, so how much is perpendicular distance of this point, sorry, of this force, frictional force, for this point? Perpendicular distance is 0 because the frictional force passes through this point. Okay, so if you consider, let's say, this point, and the force is like this, if the force is like this, then there would be some perpendicular distance, this much perpendicular distance. But if the force itself passes through the point, then there is no perpendicular distance, right? So torque will be equal to 0. So torque due to frictional force is 0, torque due to the gravitational force is also 0, right? Because it also passes through this point. So since there is 0 torque, okay, there are only these two forces and 0 torque, and therefore angular momentum, sorry, angular momentum about this point will be conserved. Let's move on to the next question. The speed of a homogeneous solid sphere after rolling down an inclined plane of vertical height h from rest without sliding is, okay, speed of homogeneous solid sphere. It is solid sphere. So this is direct question. We know V is equal to what? Square root of 2gh upon 1 plus k square by r square. Okay. So which is equal to, what is k for solid sphere? So moment of inertia of solid sphere is what? It is 2 by 5 mr square, right? And therefore k will be equal to what? If you equate this to mk square, okay, mk square is equal to 2 by 5 mr square. You can find out k. So k will be equal to square root of 2 by 5 r, or k square equals to 2 by 5 r square, because this m and m will get cancelled for solid sphere. Okay, so now we can substitute that. So what do we get? It is 2gh divided by 1 plus k square by r square. So we can directly find out k square by r square from here. If we take r square on this side, so k square upon r square will be 2 by 5, right? It will be 2 by 5. Okay, so this is equal to square root of 2gh divided by, now this is 5 by 5, 1 is 5 by 5, 5 by 5 plus 2 by 5 is 7 by 5, right? 7 by 5, and you can take that 5 in the numerator, so it is 10 by 7. Okay, so square root of 10 upon 7 gh. So option A is the answer, right? It's very simple. Okay, right. This is a direct question. Next one, a solid spherical ball rolls on a table. Ratio of its rotational kinetic energy to total kinetic energy is. So again, this is also a simple question. So what is rotational kinetic energy? There is solid spherical ball which rolls on a table. Okay, so we can say its kinetic energy of rotational motion is equal to half of half of I omega square. Okay, and I is equal to mk square, you can say. Okay, or if you have memorized the formula for moment of inertia of a spherical object, it is equal to what? 2 by 5 mr square. So you can substitute that. This is equal to half of 2 by 5 mr square. Okay, and r omega equals to v. So you get kinetic energy of rotational motion is 2 by 5 multiplied by mv square. Okay, sorry, half of mv square. Okay, and what is total kinetic energy? So total kinetic energy is equal to, we know it is half of mv square multiplied by 1 plus k square by r square. Okay, 1 plus k square by r square. So how much is k for a solid spherical ball? It is square root of 2 by 5. Okay, so k equals to square root of 2 by 5 r. Okay, so k square by r square will be equal to 2 by 5. Okay, so this is equal to 2 by 5, right? So you have half of mv square multiplied by what? It is 1 plus 2 by 5, that is 7 by 5. Okay, so we have rotational kinetic energy is 2 by 5 multiplied by half mv square, right? Rotational kinetic energy is 2 by 5 multiplied by half mv square, and total kinetic energy is what? It is 7 by 5 multiplied by half mv square. So this mv square, half mv square gets cancelled, 5 and 5 gets cancelled, so we are left with what? 2 by 7. Okay, so 2 by 7 is the answer, option D. Then next question, a disk is rolling, the velocity of its center of mass is vcm. Velocity of center of mass is vcm. Which one will be correct? The velocity of highest point is 2 vcm and at a point of contact is 0. Then the velocity of highest point is vcm and at a point of contact is vcm. The velocity of highest point is 2 vcm and point of contact is vcm. The velocity of highest point is 2 vcm and point of contact is 2 vcm. Which one is correct? This is a direct question. We have seen this. Option A. Very good. Okay. The velocity of highest point is 2 times velocity of center of mass and at a point of contact it is 0. Right? Let's see this next question. A solid sphere of radius r is placed on a smooth horizontal surface. a horizontal force F is applied at height h from the lowest point for the maximum acceleration of center of mass, which is correct? H is equal to r, h is equal to 2r, h equals to 0, no relation between h and r. Okay, we have a solid sphere and it is kept on a frictionless surface. It is kept on a frictionless surface. Sorry. Now you exert some force on it at any point. Okay, you exert some force on it. F is the force, right? So now, what kind of motion will it perform? It is saying it's option D, right? So what kind of motion will it perform? It will perform sliding motion only. Okay, very good. Everybody is saying option D, right? There is no relation between H and R. Okay, because the force acting on this body will act as if it is acting on the center of mass. Okay, the external force will act as if it is acting on the center of mass, because the external force is equal to what? Mass of the body multiplied by acceleration of center of mass. Okay, so it doesn't matter at which point this external force is acting. Okay, so option is option D, no relation between H and R. All right, next question. Consider a contact point P of a wheel on the ground which rolls on ground without slipping. Then the value of displacement of point P when wheel completes half rotation if radius of wheel is 1 meter. Okay, so consider a point of contact. Consider a contact point P of a wheel on ground which rolls on ground without slipping. Then value of displacement of point P when wheel completes half revolution. Okay, this is what we have to find out. The radius of wheel is 1 centimeter. Okay, so that is this wheel. There is this wheel and it is rolling without slipping. It's not slipping. Okay, so when when this wheel moves with half rotation, it moves with half rotation. What will happen to this point? Okay, right now it is the point at the bottom. So when the wheel rotates, wheel completes half rotation. It will reach at the top, right? It will reach at the top. So let's suppose the wheel goes over here. Let's suppose it goes over here. Okay. So now this is the point of contact, new point of contact. So this point P, it will reach at the top. It will reach here, right? So now how much vertical distance will this point cover? The vertical distance will be 2r. Okay. And how much horizontal distance will it cover? So horizontal distance we can find out. Okay, so the it rolls without slipping. Okay, so horizontal distance will be equal to what? It should be equal to pi r. Yes or no? See, this point, let's call it q or something. It was at the top. Okay, so if you take this much length, because this point will come at the bottom now, q will come at the bottom. Okay, so if you take this much length, if you unwind it, let's suppose, okay, so that circumference, so if you take this circumference, if you make it straight, this much length, if you make it straight, then if you keep it over here, then you will get this length. So this is equal to pi r, and this much is equal to what? This distance is 2r. So what is displacement of this point P? So let's suppose this point is P dash. Okay, P goes from here to here. Okay, so this much would be the displacement, right? So it is equal to square root of displacement is equal to square root of, okay, uh, pi r square plus 2r square. And what is r? R is equal to 1. R is equal to 1. So it is square root of pi square, because pi times r, since r is equal to 1, okay, it is square root of pi square plus 2 square, that is 4. Okay, so this is the answer. Option option B is the answer. Right, very good, Riti. So option B.